So as you can see, we have a total of 256 because we have 16 elements. Okay, so let's prove that our geometric model or son of freedom algebra is a group structure. So let's start. In order to prove that it is a group structure, we need to satisfy these following conditions. So first, it must be close, and associative, it has associativity, it has identity element, and it has inverse element for all. Okay, so let's start. Okay, here is it close. So since all resulting elements are contained within the set P, MA, PU, N, MO, L, PA, C, PA2, L2, MO2, N2, PU2, MA2, P2, C22. Okay, like it's a typo. So it's only one. So it follows that the geometric model is closed. So here, the first condition is being satisfied. So next one, is it associative? So to verify the associativity of the table of results in the geometric model, so it must be rotated 180 degrees like this. Okay. So the resulting table should match the original arrangement of elements to confirm associativity. So here we already rotated 180 degrees. So to better illustration. So here is the result if we will rotate it 180 degrees. So let's only focus on the results. So we need to rearrange the column or row if necessary so that the results will be similar to the original table. So it must be the same here. Okay, the results will must be the same on here on our table of results on the color red. Okay, so let's start first by rearranging our columns. So first, let's swap or interchange column 2 and 8 because we need our C to be here. Okay, so interchange to column 2 and column 8. Next one, we need to interchange column 3 and column 7 because we need our PA here. Then next, we need to interchange column 4 and column 6 because we need our L to be here. The next one, we need to interchange column 9 and column 15 because P2 must be here. Okay, next one, interchange column 10 and 14. So 10 here, MA2 and L2 because we need our MA2 to be in this column. And for lastly, interchange column 11 and column 13. So we need our PU2 here. So that's why we need to interchange it. So here is the result now. If we do all those changes, and as you can see, they are the same. The results are the same on our original table. So first P and then P here, then C22, then C22. So let's see. Okay, P and then P and then C22 and C22. Okay, so it means or therefore our geometric model or son of freedom algebra is associative or it holds associativity. Next one. Does an identity element exist? An identity element exists because there's a value P, or our identity element. So you can see here, it's being highlighted with color brown, where the row and column meet that follows the same order as the same listed around the table. So as you can see here, P, C, B, A, L, M, O, N, P, U, M, A, P2, MA2, BU2, N2, MO2, L2, BA2, C2. So C, B, A, L, M, O, N, B, U, M, A, P2, MA2, BU2, N2, MO2, L2, BA2, and C2. Therefore, it has identity element, which is the element P. Next one, does an inverse element for all exist? So in the table, as you can see, we need to locate first our identity element to know the inverse of each element. So for first one is P star P is P. So the inverse of P is P itself. So next one, C star MA is equal to P. So therefore, the inverse of C is MA. Next one is BA star BU is equal to P. So therefore, the inverse of BA is P. Then L is star N is P. So the inverse of L is N. So then MO star MO is equal to P. Therefore, the inverse element is MO or itself. So for N star L is equal to P. So the inverse element of N is L. And BU star BA is equal to P. So the inverse element of BU is BA. And then MA star C is equal to P. Therefore, the inverse element of MA is C. And then for P2, P2 star P2 is equal to P. So the inverse element of P2 is P2 itself. Then MA2 star MA2 is P. So the inverse element is itself, MA2. Then BU2 star BU2 is equal to P. So the inverse element of BU2 is BU2 as well, or itself. Then N2 star N2 is equal to P. So the inverse element of N2 is N2. Then the inverse element of MO2 is MO2. So the inverse of MO2 is MO2. And then L2 star L2 is equal to P. So the inverse element of L is L2. And then BA2 star BA2 is equal to P. So the inverse element of BA2 is BA2. And then C22 star C22 is equal to P. So the inverse element of C22 is C2. Okay. Okay, so because every row and column has an inverse element or identity element rather, which is P, so that or so it means that it has an inverse element for all. So therefore, we prove that our geometric model, which is the son of freedom algebra, which I made, forms a group structure because it meets these conditions. It is closed, it is associative, it has an identity element, and it has an inverse element for all.